Hi YouTubers, NerdArt here, and today we're going to take a look at what's inside the mystery box. Alright, let's open it up. Now, I want to apologize for the quip I made at the beginning of this video, because my viewers are awesome, you guys are not potatoes. So let's see what we've got here. And I've got, some torque sockets. That's why all you watch my videos, right? To take a look at tools. Well, these are star drive sockets. A lot of times I don't have the size that I need, so I bought a whole set. Anyway, set that aside, that's not what this video is about. Get a whole bunch of air. And this is what's interesting. A digital battery analyzer. I've been looking for one of these for quite some time now, and have needed one for a few years. I counted the number of operable lead-acid batteries that I own, and it's well over 20 for various reasons. Mainly just because I like batteries. I think they're great. But this is going to help me, hopefully, maintain them and see what condition they're in a little bit easier. Let's take a look at it. It claims that it tests voltage, cold cranking amps, resistance, and overall battery capacity. Now, for those of you who know how conductance testing works, which is what this is, it's a conductance tester, you'll know that it cannot test all of these parameters. But that's just fine, I don't expect it to. And I should also mention that there are three major types of battery testing, load testing devices out there. The standard one is just a carbon pile resistor. It's a very old technology. You just crank on a knob and turn up and down the resistance in a bunch of carbon blocks, like a bunch of clutch plates. And you can fully load your battery. If it says it's a 500 cranking amp battery, you set it so that it draws 500 amps approximately, and test your battery that way. I won't get into what cranking amps really means in this video, but I wanted to quick mention the different types of testers. And the other type that people are probably most familiar with is the type where you just clamp it onto your battery terminals and turn it on for about 10 seconds. It gets really hot, draws maybe 100 amps, maybe 200 if you have a good one, and it checks to see what the voltage of your battery is at the end of that 10-second 200 amp draw. And that gives you a somewhat good idea of what your battery capacity is. It certainly is a cheap device. These conductance meters are significantly more expensive. Midtronics, I believe it is kind of the pioneer in that market, and they cost many hundreds of dollars. This is obviously a cheap brand. CEN-TECH from Harbor Freight. Hopefully it works. We'll find out. It was a good price, got it on sale with a coupon, etc. So it finally came down to the price range where I thought I could get one. It was under $50, I think. So enough of the box. This is what's inside. A manual. Yes, let's take a look at the manual for a few minutes now, because everybody wants to see this, right? Alright, here's the device. It's not all that large. And I was somewhat wondering what the quality of this would be. It doesn't have batteries. It runs off of the battery that you clip it to. And first impressions of it are better than I expected. The packaging sure is nice. That all seems a little bit unnecessary and excessive, but like I said, rather they do extra packaging than not enough. So, the actual device here, a bunch of hard plastic all around, just like you'd expect. And it smells terrible, just like you would expect. It has this cover on it, which I guess you could call it soft, but it's, I don't know. So they give you a cover. Without that, it feels exactly like you'd expect a cheap Chinese meter to feel. But once again, I didn't pay much for it, so function is what I got it for. Looks like it has a screen protector. I'm going to remove that. Normally I leave these on, but I'm just going to rip it off this time. I usually leave them on until it gets all scratched up, and then I peel it off, and then, hey, I got a new meter again. But for this video, I'll just peel it off to start with. And the cables that it has, A conductance meter does not need to send much current through these cables. Typically they send a 1 kilohertz sine wave out to your battery, and through some technical methods that I'm not going to cover here, they can get the resistance of your battery. They do the reciprocal of that and give you conductance. So these are the two clips that it comes with. They're pretty cheap clips and pretty small, but it looks like they're about battery terminal size, no coincidence. And I wanted to see how well these were connected inside, because you cannot just put new clips on the end if they break off somewhere. That won't work. They're calibrated, and you need to have the same resistance for both of the wires. If you look inside, there's 2 wires in each of these. They use a bridge type mechanism to test resistance, because batteries frequently have 5 milliohms maybe of resistance, and the resistance of these cables is far, far greater than that. So you really need to have a matched resistance to the point of the battery. So it looks like in here they have 2 wires that come in, and one of the wires connects to one side of the clamp, this side, and the other wire runs around the hinge and connects to this one. That way they both have the same resistance to the battery. But that also means that this clip has to be connected on both sides to the battery and connected well. Anyway, this is the device. It looks alright. It doesn't feel extremely cheap. It seems like it should last quite a while. Well, let's see if it works. Any of you who watch my videos knows this is coming. I always like to take a look at the manual of products, because a lot of times if the manual is poor quality, so is the product. So I like to take a look at it just to see how it is, and really, it's not bad. It's fairly well written. There's not all kinds of grammatical errors everywhere. There's all the standard funny stuff in here. For example, this is pretty typical of these low-cost devices. They have a parts list. Yeah, how many parts are on this and what's replaceable? They have the clips and the wires and this label and that button and that button and that button, just in case you wanted to order replacement parts like a new up button. Anyway. And then also the warnings in here are kind of funny. You would think that this is one of the most dangerous tools in your garage if you read this. Do not use this tool unless you wear ANSI-approved safety glasses and heavy-duty work gloves during setup and use. Yeah, it's really dangerous. To be fair, lead-acid batteries are quite dangerous. But, you know, I've never worn gloves when working with them. And yes, you do get acid on your hands sometimes. And you know what? You just wash it off. It's not that big of a deal. Anyway, let's take a look at the product. I have a selection of different batteries here. Some of them deep cycle, one of them AGM, one of them sealed lead acid, 2 of them flooded, 1 lead calcium, 1 lead antimony, and in various conditions. They're not all in perfect shape, and that's what this analyzer is for. It's supposed to tell me the condition of the batteries. I'm not going to go into detail in this video in how this process works, why it works, how to use the analyzer properly. I should mention just a few minor things first. To test a battery with one of these, it does need to be fully charged. They claim that it doesn't have to be. It's a lie. They have to be fully charged. And you cannot have them recently fully charged. You have to remove the residual surface charge, otherwise you won't get an accurate measurement. It will read weak, that the battery is weaker if you just take it off float. And you can also not test batteries when they're in a battery bank. Lots of caveats here, but for the most part, the battery is testable under most reasonable conditions, to a degree of accuracy that makes it useful. If you have a battery that is fully charged, it may read that the battery is in perfect shape. If it's 1/2 discharged, the battery may read that it's 20% lower than expected. So it's still testable, but you won't get the same results. Anyway, I can't turn this thing on until I hook it up to a battery. So let's try out this Exide battery. This is a Exide Nautilus deep cycle battery. It is lead antimony construction, and I'm not sure if it's fully charged or not, to tell you the truth. Lead antimony does self-discharge pretty rapidly, and it may have been a month or so since I charged this battery up, so let's see what happens when I hook this thing up. Turn on the meter. Put it at an angle where you can see it, and it looks like it goes through a self-test. It also looks like it never stops going through a self-test. The manual says to hit OK, so I'll do that. And now you enter your cold cranking amps. This battery claims that it is... They don't give you cold cranking amps, they give you marine cranking amps. That's interesting. Anyway, they claim 675, so let's check out the keypad. I'll just set it to 675. 6. Wow, that's about the least responsive up button I've ever seen. And you also can't hold it down. You have to click the button, and then wait for it to flash at once, and then click it again. 6, flash, 7, flash. That's ridiculous. But fortunately, there's no real reason to type this in, and I'll show you here once it tests. It only takes about 10 seconds, nothing gets warm, it doesn't drain your battery in any way, and it will keep beeping at me until I hit a button, so I'll do that. And it claims that it is at 12.79 volts, and that the internal resistance is 3.57 milliohms, which is extremely low. I'm kind of skeptical about that. But that's the reason why I got this meter. Not many of them actually give you this much information. This one tells you the battery voltage, which is great, though I don't need this meter and a multimeter. It also tells you the internal resistance. Most of them just give you a light that says good or bad, or maybe they give you a percentage of cranking amp capacity, something like that, which is completely useless in my opinion. It's what some garage tech who doesn't care how batteries work would use the device, which is fine, but that's not what I want. So this one actually gives you a milliohm, and all the information that you need is right here, to be honest, but they do give you another screen. This one. And I typed in 670 CCA. I don't know why they do it this way necessarily, but I typed that in, and that's what I typed in. And this is what the battery actually tests at, 790 cold cranking amps. One caveat here, these are not cold cranking amps. CCA is rated at 0 degrees Fahrenheit. This battery is at about 60 degrees Fahrenheit. Therefore, it should have a lot more cranking amps than a cold cranking amp rating. Anyway, again, not going to go into details, it's irrelevant. Then they give you a bar graph up here. And this bar graph is just a percentage. If I typed in 500 cold cranking amps, and it measured anything 500 or greater, this is going to show 100%. If I typed in 500, and the meter only read 250, this would show 50%. That's all that bar graph does. In my opinion, everything on this screen is useless. But you may find it interesting, and it at least does some math for you so that you don't have to do it in your head. That's nice. And here they say that on the label, if you can read it on camera or not, it measures voltage. Yes, it does. Resistance? Yes, it does. CCA value? Sort of. That's just a lookup table from resistance, so it's one and the same. So really it's only measuring voltage and resistance so far. And then battery capacity. The only way to measure battery capacity, the only way, is to do a drain test on your battery and drain it down. But this gives you a good estimate. Basically, if you do a bunch of testing, what the data tells you is that the internal resistance of a battery when it is new, if the resistance is 5 milliohms when it's new, when it gets to, say, 10 milliohms, you're only going to have about 1/2 capacity remaining. And there's various reasons for that, but it's a good estimator of how much capacity is remaining in that battery, because the internal resistance and the capacity is directly related. But this video is probably getting boring, so let's move on. That battery reads 3.57 milliohms, and I want to see how repeatable this is. I'm just going to put it right back on, turn it on, let it test. And it reads about the same. So it seems to be repeatable. Out of curiosity, what happens if I put it on something that doesn't conduct as well? Here it's on a lead terminal, it digs in really well. Here I'm going to put it on this steel nut that just turns. And we'll see what happens then. It's not as good a connection. Is it still going to read properly? and you can see that it does not read properly. Now it says 191 milliohms. This battery would be completely useless. Look at that, I have 14 cold cranking amps. So it is very important to make a good connection on your battery with both of these clips, both positive and negative, or you will not get an accurate reading. Let's try this one more time. If I try a little harder, I think I can get a decent connection on that steel terminal, steel bolt that is. But if you have a lead post, that's preferable. And now it's 9 milliohms, 300 cold cranking amps. So it is important that you have a good connection. A lot of batteries, it's very difficult to get those. For example, this one over here. This is a battery that came out of an old vehicle. It's about 10 years old now. This is a standard Group 78 automotive battery. Group 34 has these top posts. Group 78 has the side posts. Otherwise they're the same, so this is a Group 78/34. You could use it in either type of vehicle. I'm going to use the top post for this test. Now, this battery was still working just fine when it was taken out of service. It was taken out of service because it was old, and it's better to take it out before it fails than after. I had another one, same kind, AC Delco. They make awesome batteries. These are great batteries, by the way. I had another vehicle with one of these batteries in it. After the battery was about 10 years old, a terminal fell out of it. That was a mess. So it's better to replace it early before something like that fails. But any battery like this that lasts 10 years, that's pretty good in my opinion, no matter how it fails. Hook the meter up and let's see what it reads. This battery is old and it was taken out of service because it was old. And again, I'm not going to type in the cranking amps every time because it doesn't really matter. And here it says 5.6 milliohms. Not bad at all. 490 cranking amps. So this battery is weak. It started with 650, I think, cold cranking amps, probably about 800 cranking amps. And really, because it's warm, this is going to be measuring cranking amps. And this battery is maybe about 60%, which is plenty good to start a car. Cars will start off with batteries that are absolutely awful. But this shows that this battery is getting weak. It was probably good that it was replaced. Let's move on to another battery. I'll hook it up to this Autocraft battery. This is also a deep cycle battery, but it is a lead calcium construction instead of lead antimony. Also a flooded battery like that Exide battery was. And I know that this battery is in very good condition. This one claims that it has 550 cold cranking amps and 685 marine cranking amps. So we should get about 685 according to the battery's rating. And we get 712. That's, again, very close. So far this meter looks like it's working pretty well. We'll move on to one more battery. This here is an AGM battery. It is a deep cycle battery, one of the highest quality batteries that money can buy. I happened to get it really cheap, fortunately. And it should be fully charged and in very good condition. This one's interesting because it does have steel posts. So let's see if I can get a good enough connection on this to actually test it. Now, this is a deep cycle battery, but it has around 1,000 cranking amps. And that's because this is one of the best batteries on the market. So let's see how this works, if it works, on these steel terminals. Turn it on, hit OK. It's not the most responsive thing, but it seems pretty solid in your hand. And it looks like it worked alright. This battery has been recently charged. You can see it still has some float charge on it, but the readings here are still pretty accurate. I've tested this already a little bit, and it doesn't seem to matter a whole lot as long as it has been off the charger for a few hours. After that, the readings seem to stabilize. But here it shows 1,100 cranking amps on this battery, and that's about what it should be, brand new. So it does work even though these terminals are steel. So far, I kind of like this thing. But let's do one little test here. I'm going to hook it up to this Exide battery, turn it on, tell it to test it, and set it right here. and then tell it to shut up because that's annoying. I wish it didn't do that. And I have another multimeter here. I'm going to see. It says 12.78 volts. How accurate is the voltage? I know that this meter is pretty accurate, so 12.80, which is very, very close. This meter is about 10 millivolts high in voltage when you're measuring a battery, so this is very, very close to correct. Now this Exide Nautilus battery was purchased at the same time as another battery, and it has been treated the same as that other battery, up until just a little bit ago anyway. And this one is saying 3.6 milliohms about, and 780 cold cranking amps. This battery is warm. Let's go out to my garage where the other battery is being stored right now.